This is 1969, number 21. So all the questions as we see here are regarding increasing, decreasing, relative max, relative min, all have to do with the first derivative. And so let's go ahead and find the first derivative. Oh, and this one actually discontinuous means that there's a vertical asymptote or a jump discontinuity or a hole. Now let's look at this. X squared is continuous everywhere. It's just a parabola. And then e to the minus 2x. So e to the x looks like that. It is continuous. If you put a minus in front, it flips it. That's e to the minus x. And if you put a 2 there, it's just gonna scrunch it towards the middle. It's still continuous. So you have to understand that this is continuous and that's continuous, therefore it's continuous. So that's out of the question. We know it's continuous. That's not going to be the answer. So let's find the derivative. It's going to be 2x plus. Now the derivative of e to something, that's not x, so it becomes box. The derivative of e to the box is I am my own grandpa, so it's e to the box times derivative of box. So now we have this. Now, we could do a couple things here, but to be always increasing, this would always have to be positive. And to be always decreasing, this would always have to be negative. So let me factor that and let's see if we can figure this out. They both have a 2. And if we want to find our critical points, we set that equal to 0. And I'm not sure what this is going to look like right now. So I'm going to add e to the negative 2x to both sides. So we're just going through the process as if we're trying to find a relative maximum min. So we're trying to find the critical points. I need to ln both sides to get rid of the e. Those will cancel. So I'm going to get ln of x equals negative 2x. Divide both sides by negative 2. So I'm going to have x equal ln of x over negative 2. So here's the problem. I'm trying to solve for x, and I have an x on both sides of the equation. So we're going to have to use some logic here to figure out what's going on here. So let's evaluate this. X, y equals x looks like that. And then e to the minus 2x, let me draw that. It's going to look something like this. So the derivative is going to be that minus that. It's going to be the blue minus the pink. Now let's look what's going to happen on all of these here. And I think we're going to figure this out. If you took the y value here minus the y value there, it's going to be a positive number because you're taking a big number minus a small number, so it's positive. And all the way here, that minus that is going to be a positive. And here, if you subtract the blue from the pink, it's going to be 0. So let me write this down here. There, f prime is going to be 0. Okay? And like, let's look right here. F prime there is going to be positive. Now let's look on the other side here. Let's do, what color haven't I used? Brown. Right here, if you do x minus that, you're doing the blue minus the fuchsia. That's going to be negative because you're taking a smaller number, subtracting a bigger number. So we know f prime is going to be negative there. Now this is kind of weird, but the derivative is negative over here. positive over here, and 0 here. So the derivative changes from negative to positive at that point, giving you a relative minimum. So the answer is going to be D. We know it's not A and B because the derivative is positive here, meaning f is increasing. The derivative is negative here, means f is decreasing. So it has both increasing and decreasing. So it can't always be increasing, can't always be decreasing. But as you look at this, you can kind of figure out that, yeah, the derivative changes from negative to positive.